Hello guys, you're welcome. Today we intend to devise a new means to add fractions that is unlike fractions, and the means is using equivalent fractions. First of all, let's look at what equivalent fractions are. Now, equivalent fractions are said to have the same value numerically and spatially or geometrically. Example is 1 out of 2 and 2 out of 4. For example, if we believe that these are equivalent, it means that their geometrical or spatial representations are equal. So looking at the spatial representation of 1 out of 2, it covers half of this whole space that has been given. Now looking at the geometrical representation of 2 out of 4, it also covers half of this whole representation. This implies that they are spatially equal. Now numerically, 1 out of 2 can be written in the decimal form 0.5. Similarly, 2 out of 4 can also be written in the same decimal 0.5. Now let's look at how we can devise the equivalent form of fractions. For example, 1 out of 2. To write the equivalent form of this fraction, the easiest way to go about it is to use the addition method. What we do here is that we add the numerator to itself consistently and also add the denominator to itself consistently. So 1 is the numerator. To get another equivalent form of this fraction, we add 1 to itself to get 2. We add 2 to itself to get 4. We can continue the pattern by adding 1 to 2 to get 3, adding 2 to 4 to get 6. This pattern can actually be continued. It can be continued. Therefore, we can also add another 1 to the 3 to get pardon me to get 4. We can also add 2 to the 6 to get 8. Let me input the equal sign for easy identification. We can continue this process by adding 1 to the 4 to get 5 and adding 2 to the 8 to get 10. Right. So this process is actually infinite. You can continue the process. Let's add another one to see. One last one to see. Then 1 to the 5 will give us 6. 2 to the 10 will give us 12. Now, this implies that 2 out of 4, 3 out of 6, 4 out of 8, and 5 out of 10, together with 6 out of 12, are all examples of equivalent form of 1 out of 2. That notwithstanding, let's try to pick 2 out of 4 and try to find a equivalent form of this fraction. So 2 out of 4. So 2 out of 4 together. Good. So using the same addition approach, we can say that should we add 2 to 2, you will get 4. 4 to 4, we get 8. Good. We can continue with the process and see we add 2 to 4, we get 6. We add 4 to 8, we get 12. This process can continue unabated. Actually, the list of equivalent fractions are infinite. We add 4 to 12 to get 16. We add 2 to 6 to get 8. Good. let's rest here and look at how we're gonna do these process. So 4 out of 8, 6 out of 8 together with 8 out of 16 are all equivalent fractions of 2 out of 4. Brilliant. Good. Now, let's look at how we can apply this approach to solve this question. In a traditional setting, we are always told that we can actually use in a traditional setting we are told to look for the LCM. We are told to look for the LCM of such a fraction to be able to solve it. Let's look at how we do that before we come to our very own newly devised approach. Now, we are told to always look for the LCM of 3 and 2. That should give us 6, right? So the 6 is written down here. Then we look at how many times 3 will enter 2. And we are told it is 3 will enter 6. Pardon me. We are told it is 2. So 2 multiplying the numerator top here will give us 2. Then we come down and look at how we will 2 will enter 6, and that will be 3. That 3 multiplied by this 1 will give us 3. So this will culminate into us getting the answer to be 5 out of 6. Good. Now, in our own approach, what we do here is to establish or detect or list each of these fractions with their equivalent fractions. So we start with 1 out of 3. So 1 out of 3 can have a list of equivalent form like so 1 plus 1 2 3 plus 3 6 1 plus 2 to give us 3 3 plus 6 to give us 9 again 1 plus 3 to give us 4 3 plus 9 to give us 12. Good. Now let's invite the case for 1 out of 3. 1 out of 2 rather. Remember, we already have 1 out of 2 listed in our previous area, so I would quickly go there and pick those ones. So good. Good. So you realize that we have a list of these fractions equally given us. So we have fractions, equivalent fractions of 1 out of 2 also listed below. So we, the next procedure we go by is to look for the fractions which are actually same or like. Good. In that manner, we shall select the ones with the same base. Those fractions having the same base. Good. We shall select those fractions having the same base in each of the two fractions listed. We realize that 1 over 3 has 2 out of 6. Then 1 over 2 has 3 out of 6. Good. So these two have the same base. What it implies is that we can continue this process by rewriting here. We rewrite here with 2 over 6 or 2 out of 6. So 2 out of 6. So equally, you continue by selecting 3 out of 6 since both 2 out of 6 and 3 out of 6 have the same denominator. So 3. So 3 out of 6 will represent that of uh, 1 out of 2. So they then result to a fraction with the same base. Fraction with the same base. So that is like fractions. Therefore, we can add the numerators, which is 2 and 5, to give us 5 out of 6. Good. And that is the expected answer as we did initially. So let's try to make it more visible to our eyes. Alright, so ladies and gentlemen, more follow-up videos on this will be done. It's actually simpler, especially more appealing and easier for students who have difficulty in trying to find how many times a certain number enters how many certain number. Thank you for now and see you soon. Bye.